So why do our cis form at all? Because of this very strange, and I do admit it's strange. So the Hopital's rule. Hopital is one of the most famous mathematicians we have. He came with several bits of genius. This is one of them, which is really, 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 really weird. I hope you're paying attention because I'm not doing this twice. Oh, no. Well, actually, I guess I am. I'm not doing it twice for you guys, though. Okay, so what if I was going to take two R cis's and for whatever reason I was sick enough to want to multiply them? Now remember, we're talking about multiplying two things like 2 plus 4i times 3 plus 2i, right? Still be easier, but I'm gonna use this rule anyways to start doing other things that are really extraordinary. So the first thing I do is this. I point out the following, that this is really shorthand, right? So I'm going to change it to R1 cosine theta 1 plus I sine theta 1 times R2 cosine theta 2 plus I sine theta 2. Ah, that didn't help me at all. So far, so good? Now, you guys all know how to FOIL, correct? So we're going to put the R1 and the R2 together, and I'm going to start FOILing, because that's fun too. So I look over here and I go, cosine theta 1 times cosine theta 2, that's cosine theta 1 times cosine theta 2. FOILing, right? First, outers, plus I sine theta 2 times cosine theta 1. I'm multiplying this times this, then this times this, right?
Oh, okay, I was looking at
FOILing, inners, plus I sine theta 1 cosine theta 2, agreed? Plus I squared sine theta I sine theta, I'm saying I, it should be 1, right? 1 and 2. Sure. Isn't that fun? In parentheses.
Beautiful.
Now I'm going to take the I squared thing here, I'm going to turn it into a what? -1. And so I get the exact same thing except I get with a negative sine theta 1 sine theta 2. Would you allow me to just let the rest of this fall down? Agreed? Now I'm going to look at this and go, well, that's interesting. I'll just put a line through it, light line through it, so you guys can follow along. Now, this is real, and these two pieces are imaginary. So I'm going to gather them. Is that okay with you? I'm going to gather these two together, and then I'm going to gather these two together in a lump. So I'm going to write this as R1, R2, cosine theta 1, cosine theta 2, minus sine theta 1, sine theta 2. And that's the real part, right? These two pieces don't have an I on them. Plus I, parentheses, sine theta 2, cosine theta 1, plus sine theta 1, cosine theta 2. And I'm going to pause there because we are right at an epiphany moment. And based on the question you asked me earlier, the epiphany is going to make almost no sense at all. We're going to say peanut butter and something magical is going to happen.
So it's not an epiphany.
Oh, it is an epiphany for the rest of you. Because when have we heard cosine one angle, cosine the other angle, minus sine one angle, sine the other angle? Somebody's pointing up here. Miss Sachs, what are you pointing at? Cosine of one angle, cosine of the second angle, minus sine the first angle, sine the second angle is cosine of the two added up, right? So I could rewrite this first one as R1, R2, cosine theta 1 plus theta 2, which is weird. Moving forward. What about the second one? That's a sine one, right? Plus I sine theta 1, theta 2, plus theta 2. Because remember sum? Sine 1, sine the other, plus cosine 1, cosine the other is just the two added up, right? That's all I did. Change that, and the two added up. I did that identity we've done forwards like 512 times. We did it backwards this time.
What happened to the negative?
So then you just.
Well, the negative on this one, remember on the cosine identity, when it's a minus on top on the right, we would use a plus on the left, wouldn't we? That's interesting. Now, because we're lazy mathematicians like everyone else, I'm going to rewrite this as R1, R2, cosine plus I sine. Somebody said cis, and they're correct. Cis, theta 1 plus theta 2. So, R cis theta 1 times R cis theta 2 is equal to R1, R2, cis theta 1 plus theta 2.
Nice.
By the way, it's written on the wall over there. I probably should have turned off the light when I did that. Look, it's written on the wall right over here. Under the things you should not have put on your final because that would be ridiculous and you don't know how to use it. How many times you use that on the final? Twice one. Okay. So everybody take a look at the very first problem. Let's blow through it as fast as we possibly can. Go. Try the first problem. I want it in polar form. It's 4 cis pi over 3 times 7 cis 2 pi over 3. People in the front row are talking too loud and you don't want to talk over you. So, what is this? Well, it's 4 times 7 cis pi over 3 plus 2 pi over 3. Oh, yeah. So 4 times 7 is? It's not 21.
28.
Oh my God.
28? Cis? What's pi over 3 plus 2 pi's over 3?
Hi.
Pi. So there is my cis form. What if I want to turn that back into rectangular? The normal rectangular.
Find out the cosine pi.
So I go 28 cosine of pi plus I sine of pi, right?
Yeah.
28, what's cosine of pi? Da-dee-da-da-da-dee-da.
Negative 1.
What's sine pi? 0. Love it. So now distribute.
Negative 28.
Negative 28.
That's the rectangular form.
That's the rectangular form. These are technically both rectangular form. One's the cis form and one is the rectangular form or standard form. Yes, sir.
How do we distinguish between like an X or Y if you don't like if one of them is undermined to the other?
Yeah. Now we're thinking. I like it. I like it. Great question. Great. Even better. Yes.
Did you just get over pi?
But it's awfully easy once you get used to it. Right? I mean, I'm on the back. So 6 cis, 3 pi over 4 divided by 2 cis. I don't even think you memorized the formula, am I? Right?
Oh, it's
So
already
you just
there.
look over there and you're going to go 6 divided by 2 cis 3 pi over 4 minus pi over 4. 3 pi's over 4 minus pi's over 4 is pi.
Over 2. From pi over, yeah. Wait.
Isn't it pi over? No, it's pi over 2. You're right. I'm wrong. 3. So that's my cis form. And then if I want my rectangular form, what do I have to do?
What's cosine of
3 cosine pi over 2 plus I sine pi over 2.
So that has.
that crazy?
So what is that?
Zero.
Addition to subtraction.
No, division turns into subtraction. Multiplication turns into addition.
Wait. But that stays addition up there.
Yes, that's the cosine plus I sine stays the same. That's not going to change. Cosine plus I sine, so I got cosine, which would be 0 plus I times 1. I get 3I.
What did you get?
Do I know that?
So this is the first time we've done a problem that was actually easier to do with cis form. Because if you divide by 2 cis pi over 4, that would be something plus something I, which means you'd have to simplify it. And that would be unfortunate.
Yep.
You should do number.
Square root of 3 over 12 plus 1.
I did number. Did I thought I did number 1.
Oh, no, number 2 is right.
Can't add this.
Can we do an SAT practice?
Oh yeah, we're supposed to do that too, aren't we? Oh gosh, no, I'm done. It's not
Can we do
Wednesday.
number 2 on this one later?
What?
Can we do number 2 on this one later?
All right, let me do 2 now, and then we'll do that SAT question, and then we'll do that.
Okay.
So why is 2 got you though? I'm a little weirded out. 6 cosine pi over 2. So sorry, cis pi over 2 divided by 2 cis pi over 3. Should be 6 over 2 cis pi over 2 minus pi over 3. That would be 3 cis
3 minus 2.
pi over 6. Oh,
Negative 5
and then it would be 3 cosine pi over 6 plus I sine pi over 6. That'd be 3 root 3 over 2 plus I times 1/2. So that would be 3 root 3 over 2 plus 3 over 2 I.